Alright guys, so I want to take a few minutes to give you a video to introduce you to exponential functions. Most of you are already pretty familiar with these. You probably did it last year in Algebra 2, but if not, I'm going to take you from scratch. Alright, so what I have here is a pretty basic exponential function. Okay, exponential means that the independent variable is the exponent here, right? Not that there is an exponent, but that the independent variable is the exponent. Oops, sorry. We also have usually some type of constant or parameter, some value here that is the base of the exponent. And then we also have the dependent variable, which is on the other side of the function. Now, we can add things to this function, subtract, multiply, divide. We can do things to this function, but this is kind of the parent function, the base function. All right? So what I want to do first is just kind of look at a bunch of different exponential functions and get an idea for what they look like. Okay? Now, there's a couple of things I want you to notice. All right? Getting the y-intercept for these types of functions is really, really easy, right? To get the y-intercept, we just make x equals 0. And so if I put 0 in for x, then I get y equals 2 to the 0 power. And of course, anything to the 0 power is 1. So I get y equals 1, which we can see right here on the graph. Notice that each one of these marks is 1/2. Okay? So now, the other thing I want you to see is that right here, we've got something that we call a horizontal asymptote. Okay, now this horizontal asymptote is at y equals 0. Now what the horizontal asymptote means is that as I look at my graph, right, this graph right here, as I come back this way, as I get farther and farther, as I go to negative infinity, this graph is going to get closer and closer and closer to 0, but it's never actually going to be 0, right? Try to think of, for just a minute, try to think of a situation where 2 to the x power equals 0. Okay? And you won't be able to come up with something. Go ahead, think as long as you want. You won't be able to come up with anything, right? Even if I put a negative value in for x, if I go y equals 2 to the negative 1, remember what a negative value does is it can flip the fraction. And so this can become y equals 1 over 2 to the positive 1, which is 1 over 2, which is just a fraction. It doesn't ever become 0, and it won't ever become negative. And so because of that, the further I go, right, if I do y equals 2 to the negative 100, that becomes 1 over 2 to the 100 power, which still isn't going to be 0 and isn't going to be negative. It's going to get smaller and smaller and smaller, right? 2 to the 100 power is a huge number, and 1 divided by that is going to give me something very close to 0, but it won't be 0. And so therefore we say that there is a horizontal asymptote at y equals 0 because the graph will never actually equal 0. All right? Let me show you a couple other exponential graphs. All right? We've got the one that we just looked at, the y equals 2 to the x power. And then I've got a few more. I wanted you to take just a minute and look at these different graphs and then kind of describe to me what you see. All right, so pause the video, take 2 or 3 minutes, write down what you see, and try to think about the things that we talked about on that previous slide, and then we'll come right back to this. All right? Okay, so hopefully you did that. One of the things that I hope you recognize is that all of them have this horizontal asymptote. Right? So horizontal asymptote, right? All of them have this horizontal asymptote where y equals 0, just like that. See? Every single one of them has exactly the same horizontal asymptote. That's because we haven't moved the graph at all, right? The base has changed. Each one of these has a slightly different base, but they all have a horizontal asymptote at y equals 0. We'll look at some in just a minute which don't, but for now, they will. They will have a horizontal asymptote. Okay, another thing I want you to recognize is the y-intercept. Okay, notice for all of these, the y-intercept is 1, right? And you can see, except for this one right here, which is -1, because that's a negative 3 to the x. So remember, when you take something 3 to the x, which would be the same as all of these others, and you put a negative in front of it, it causes a vertical reflection. And that vertical reflection means that everything that was up on the top, right, 3 to the x would look something like this, that has now been flipped upside down, and so now my y-intercept is -1. All right? Okay? So, yeah, so all of them have the same y-intercept. We haven't changed that. Changing the base doesn't affect that. Now, the other thing I want you to see is that some of these graphs are what we call exponential growth. They're all exponential, but some of these have exponential growth. Okay, and if you've looked at any of the statistics recently about the coronavirus, what you see is exponential growth, right? For example, one person goes and they affect 2 other people, and then those 2 people go and each one of them affects 2 more people, right? So it goes from 1 to 2 to 4, and if each of those 4 affect 2 more, then we go up to 8. Each time it's getting larger and larger. You may recognize that as being a geometric sequence, which we'll talk a little bit more later. But the idea is it exponentially grows. It's not a linear growth, it's not quadratic, it's exponential. Every single time we're multiplying by the same number. In fact, the number that we're multiplying by each time is the base, right? 2 to the x means each time I go 1 over, it gets multiplied by 2. Go 1 over, it multiplies by 2 every time I go over, right? And so you can see 1, 2, 3 of these that have exponential growth, okay? Now, if you have a positive base and a positive exponent, then you get exponential growth, okay? Now, hopefully one of the things that you mentioned, you noticed, is that there is also this thing right here, which is exponential decay. Every time it gets a little bit smaller, a little bit smaller. Well, why would that happen? Well, right here, the base of the exponent means that every time x increases by 1, I'm multiplying by 0.5, and 0.5 is 1/2. So it's like having a constant ratio of 1/2. Every time I progress to the next number, it gets halved again, and you can see that here. It starts at 4 at -2, and then at -1 here, it goes down to 2, then it goes down to 1, then it goes down to 1/2, right? Each time it's getting halved, 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 halved. Again, geometric sequence, right? Now, this idea is going to be important in recognizing that any time that this value is less than 1, then we get exponential decay. Okay? Now, that's all with a positive x. But remember, anytime your x is negative, that just means flip it. So if you have a 2 here, 2 to the negative x power is the same thing as 1 over 2 to the x. All right? Now, if that's 1 over 2 to the x, then that now gives me this situation where it's 1/2 to a power, and so therefore I get the exponential decay. So 2 things are going to cause decay. If the value here is between 0 and 1, if it's a fraction less than 1, or if you have the negative exponent. Okay? Now, one thing you see in this 5th one here is that I have a fraction less than 1, 1/4, and a negative exponent. And when you put those 2 together, you get a exponential growth again. Okay, so one of those 2 things, either the fraction for the base or the negative x, will give you decay. But both of them together will put it back. It's like a double negative. Will put you back into positive again. Okay? Awesome. So hopefully you're recognizing all those different ideas, recognizing growth, recognizing when it's decay, and you're able to kind of put all those ideas together. One more I'd like to do in this video is this example right here, okay, where I've got y equals 2 to the x and 2 to the x minus 3. So you can see here that I have the normal y equals 2 to the x. That's the same one that we've been using. What happens when I put a minus 3 on there? Now, some of you will recognize from transformations that that means that the graph is going to move down 3. Now, it doesn't look obvious because the graph is a little bit different shape from your linears and quadratics and other things that we've shifted up and down. But I want you to look at the y-intercept here. The y-intercept was at 1. Where is the y-intercept now? It's down at -2. It was at 1. It's moved down 1, 2, 3 spaces right there. How about this point right here? This point right here was 1, 2. Where is that point now? Well, instead of being at 1, 2, it's now down 1, 2, 3. It's been moved down 3 spaces, right? Any point that you take off of this graph, that one is 2, 4. So 2, 4 was right here. 1, 2, 3 spaces. Every single point has been moved down 3 spaces. Now, not only does that move the whole graph down 3 spaces, right? We take our y-intercept down, is now at -2 instead. Take a note of this. My horizontal asymptote sorry, I was using red before, my horizontal asymptote used to be at y equals 0. But what happens if I subtract 3 from everything? Where is my horizontal asymptote at now? Ooh, it is at y equals -3. Look at that. So this number right here that's being subtracted on the outside is basically where my horizontal asymptote is, right? This was 2x, 2 to the x, plus 0, so the horizontal asymptote's at 0. This number right here represents the downward shift or the upward shift, depending on the question, and therefore also tells me where the horizontal asymptote is. That's pretty cool stuff. All right? You can see it once more right here. The same idea, right? This time I'm adding 1 on the outside. Take each of those points. The y-intercept used to be 1. If I add 1 to it, it goes up to 2. This point right here, 1, 2, used to be right there, 1, 2. Look at that. It's been shifted up 1 place, right? 2, 4, 2, 4. Look at that. Shifted up 1 space. So it's just a transformation. Everything's been shifted up 1 space. The asymptote as well, look at this. Here's your horizontal asymptote. Horizontal asymptote as well has been shifted up 1, just like the rest of the graph. Everything has to be moved the same amount. All right, so hopefully that makes sense. Go ahead and watch the next video, and I'll give you some examples of some applications, all right? There you go.